5 minutes. Okay, to your point, single file server is a single point of failure. Think about your SAN, multiple controllers. If one fails, the other controller takes over the workload, thanks to MPIO. If you've got one of your switches and your SAN fails, the other one's there, you've got your networking crossed over and everything, so you've got basically dual path fault tolerance. Single file server, if you have to patch it, it goes offline. If you're storing SQL databases and Hyper-V virtual machines in there, they won't like that. They won't like their storage disappearing for 10 minutes, because we all see how long it takes a server to boot these days. So that's not good. So we can create clustered file shares. Anyone ever done a clustered file share before in 2008 or 2 or older? 1, 2, 3, 2. Okay, basically, pair of nothing. Move it over, whether it's proactive or reactive, and that could have an outage of maybe 30 seconds, which again would be a P45 generating event. So what we want, and this is 2012 drinking game, this is 2 shots, scalable and continuously available storage. And Dave alluded to this earlier. The concept is we create a new type of file server storage or cluster called a scale out file server, or SOFS. Where did I see SOFS earlier in my demos? And what we do, active backend storage is cluster shared volume, something we first saw in 2008 or 2, and they've fixed in 2012. And I'm serious about that. The file share exists on both nodes at the same time, but as a single physical storage in the back end, which could be our JBOD running storage spaces. Our fiber channel SAN, because we've run out of ports, or we're running out of ports on our fiber channel SAN, we can't afford to buy new switches. It's cheaper to buy a pair of file servers. They come with their 8 gig of RAM. Think about that, the OS needs 2 gig. I've got another 6 gig, which is now going to be my read cache. A read cache of 6 gig, pretty nice. For VDI, even better, because we can alleviate that boot storm using something called CSV block. If this guy goes offline for whatever reason, there's a witness process. And basically, this guy knows that this guy's gone offline. This guy, who was writing to this path to the share, queues up his I/O and is redirected to here. The hood, you don't need to know about it. That I actually had this running accidentally in my demo lab for about 3 months and didn't know it. I actually did a live demo where I shut down one of these and my Hyper-V virtual machines just stayed running. And I completely forgot to turn the other node back on again. If I can get a few minutes, I will build one. Okay, so a good chunk of what we wanted to do is done. No, it can be JBOD. But can the JBODs be in 2 separate data centers? No. No. So the role for a SAN isn't completely gone. SAN does have some hardware features that JBOD can't do, and storage spaces can't do it yet. But it's only a matter of time, I think, at this point. The architecture will be some sort of storage on the back end, potentially a JBOD, could be reusing our existing SAN investment and extending it beyond its switch port capacity, or taking advantage of the software defined storage that file shares give us. Pair of file servers, these are going to be clustered. One of the requirements for SMB multi-channel, if we're going across multiple NICs, is that both the NICs must be in different subnets. Some people have seen that in iSCSI and the SAN vendors, where both iSCSI NICs must be in different subnets. Create a witness disk. It's basically a virtual disk in my JBOD, my storage space. Create a cluster. On the cluster, I'm going to create a special role. It's a file share for application data in the GUI. We refer to it as a scale-out file server. That will basically create a computer account in Active Directory, and that's the thing that will basically our application servers will be connecting to. The file shares will be associated with this. It will reuse the IP addresses of the physical node members. And then we create a volume that we're going to have our shares on, or our share. And then we create the share in a scale-out file server role, and I'm going to do this in a second. And it exists on all the nodes in that cluster. That cluster, between 2 and 8 nodes. That's like having between 2 and 8 controllers in your SAN. And remember, their RAM read cache. So that's a whopping big read cache. Okay, let's create one as quickly as possible before Dave starts screaming at me. Okay, 45. So I'm going to create a cluster. I'm not going to do the validation because it should validate fine anyway. Demo fs1, demo fs2, and add, next, and demo fsc1, and let's call it 64, next, next, and it's adding all the storage in. So it'll find the 1 gig disk that I created in the iSCSI target earlier. It's going to use that as the witness disk for quorum. And it'll find the other volume and it'll add it in. Now tomorrow I'm actually going to be doing this using PowerShell for a Hyper-V cluster that will be storing virtual machines on this scale-out file server. Finish. So there's my cluster. What I would normally do at this point in my cluster is I'd go in and I'd rename all these networks. So there's 6 networks in here. There's 2 for iSCSI to connect to my backend storage. There's 2 cluster networks for communications. And then there's my 2 front-end NICs for my SMB multi-channel. So that's what the clients will connect through. Under storage, you'll notice there's changes in here. Pools is if I had a JBOD that was connected to both my file servers, I would create my storage pool in here and create my virtual disks in here. Under disks, I can see I have 2 disks. Again, I would normally, if I had time, go in and rename these. And this is going to be my cluster shared volume. To do cluster shared volume now, I just right click and say add to cluster shared volumes. And that is now a cluster shared volume. And it's mounted on both servers on our C cluster storage, volume 1. So that folder now exists. That mounted drive now exists on both the cluster members in this architecture. Roles. Configure roles, next, file server, next, and I have a choice. File server for general use is the traditional active passive file server cluster for end user file shares. The one we're going to use is application data and should only be used for application data. So things like SQL Server, Hyper-V, IIS. This should not directly store end user file shares. If I want that, I'll go for the active passive type. There's a deep architectural reason for that to do with performance. So now I'm going to call this demo SOFS1. Next, next. We should see a failure come up, and I've deliberately done this. Finish. That will fail. And most of you who ever deploy this configuration will see that fail. So what I'm going to do is, what's actually happening is my cluster is trying to create a computer account for my scale-out file server in Active Directory, and it doesn't have permission to do it. So what I will do is go to Active Directory user computers. There is, if I refresh this, my cluster computer account. What I'm going to do is properties, security, advanced, add, select principal, object types, computer, okay. Demo SOFS. No, it's FSC1, so it's the cluster. And I'm going to be lazy. What I should say here is create computer accounts. I just don't have time to browse down and select that, so I'm going to give it full control. Please say, do as I say and not as I do. So it's create computer account is the right I want to give there. Because I've just made it a full admin of that OU at this point, so it can create group policy and everything. So now if I go back to my thing and start this role, it's now running. So now I basically have the scale-out file server up and running, but it has no shares. So what I want to do is right-click, add file share. So this is now the equivalent of what I've done so far is I've set up a SAN, and now I'm going to create a LUN in my SAN and zone it to some servers. And where am I going to store it? I'm going to store it on my CSV, which up to now I've been calling CSV1. I've been very particular about it. I'm going to call it CSV1 here again. And then quite handily, it gives me the UNC path right there. There's the computer account for my scale out file server role, and then share CSV1. Next, if my network is open, I can encrypt the SMB traffic just by checking that box, so it's nice and secure. It'll do all the Active Directory stuff for that. Next, customize my permissions. Which hosts, which administrators need full control over this share? So you would put in the security groups for those particular things in there. So I should be able to do Hyper-V, check names, hosts, give them full control. And I would do the same for the administrators. So that's the file system, and that's the share. By default, the share is everyone has full control. Please do as I say and not as I do. Customize this as well. So only the hosts have full control over that. Next, create, close. Now I can see my share is here. If I want to edit the properties, I can hit the properties there and it'll open up a nice little wizard where I can browse through and change the share permissions and all that good stuff. Now if I put in the path, and now I can start creating my virtual machines in here. So that's the path I would now use on my Hyper-V hosts or my SQL servers, whatever it is. Instead of d:// I would put in the UNC path. It's a file share in the end. So, quickly wrapping up. This is a possible architecture you can deploy for the real world for big mad deployment. This is one using multiple JBODs with three-way mirrors and all the various networking stuff. And if you have a look for that Hyper-V over SMB performance considerations by Jose Barreto, big long article, and he highlights where the various bottlenecks may be in that architecture. Jose Barreto, for SMB3 storage, he's the dude you need to know about. You'll find all his presentations from MMS and TechEd on Channel 9, free to download, and the slide decks as well. So, get to know SMB3. Jose Barreto. If you have a look for him, he's easy to find because just about anyone who's looking for this stuff, B-A-R-R-E-T-O, single T. So, it's no point in sticking your fingers in your ears and pretending this stuff doesn't exist. This is here. You need to start learning this stuff if you work in the Windows world. Even if you don't work with Hyper-V, you should. But even if you don't, you need to start learning this stuff because it's simpler, it's cheaper, and it can offer better performance than traditional block storage. Very quickly, ODX. If you want to create fixed virtual hard disks, if your SAN supports ODX, it's a SAN feature, you can create yourself a fixed virtual hard disk in about 3 seconds instead of waiting 20 minutes. Trim and on-map are now supported, so we get better utilization of disk space if your physical storage offers. We now have spot checking by check disk, so that big multi-terabyte volume doesn't take 3 hours of downtime to do a check disk. It will actually do it on the fly while your services are running. And refis. And that is that.